Hello, YouTube. We are reading, today we're going over chapter, I think, 16, Enterprise Auth for Enterprise of the book Devops for Data Science. Um, this will be more of a discussion, I guess, than a lecture since I think that's generally good practice, but also I am a little unprepared. So we can dive into it. So I'll share my screen. Do this one. Oops. And do this one. You can all see the slides now? Okay. So these are the slides from the previous presenter. I haven't had a chance to tweak them, but or read them in detail, but we'll go through them and just have a discussion. Feel free to jump in whenever you want with thoughts, opinions, feelings, concerns, anything like that. Um, Today, the learning objectives are to understand auth, AUTH, as a catch-all for authorization, and I suppose the preceding step, authentication. So we'll touch on that distinction in a little bit. We'll also aim to understand different ways to manage permissions, grant access to different services within your company, your enterprise, and the advantages and drawbacks of each. We also will hopefully talk about token-based authentication and kind of crack open what a token is. It was news to me, but I learned a little bit that I'm happy to share. And I think we'll try to also disentangle a lot of these, again, to me, new acronyms, LDAP, IDP, SAML, SAML, and understand when they're competing technologies, when they're kind of newer and deprecating technologies, and what are wrappers around other technologies. So we'll try to make sense of the spaghetti that is all of that. So at your organization, at every organization, the goal of Auth, AUTH, is to make two things possible: authentication and authorization. Authentication, we'll touch on what those are exactly, but you basically want to make sure people are who they say they are, and that those people have access to the services they're trying to reach, whether it's like email more generally, database, an HR platform, any service, very loosely defined, where someone might need to, uh, with limited permissions, i.e., a password. It's not just generally open. You have to get through the limited access hoop in some way. Managing auth at an enterprise is challenging, and that's why we have like chapters and IT specialists who do it for us, because people leave and join not only your organization, but they move around different teams. The policies around access for your different services changes. So it's a bit like musical chairs. Everyone's changing rooms. It's like musical chairs kicked up a notch, because not only are people moving chairs, they're moving rooms. Sometimes they're moving buildings, if we want to stick with that analogy that the book uses. The approach I think most enterprises take is the idea of least privilege, which is almost, I think, so ingrained to thinking that it almost doesn't need much discussion. Like, you don't join a company and you get access to everything from HR records to databases to social media accounts. Like, you just get access to what you need to do your job. And that's just called least privilege. You have access to only what you need to do your job. Everything else is hidden from you. So Auth, is, I guess, the domain that IT and admin specialists work on that controls all of that. Who gets access to what? How do we know these people are who they are, say they are, and things like that. So it's kind of an interesting field, more interesting to me than I thought it would be when I signed up for this chapter. But let's maybe dive into a bit more. I'm going to flip back and forth between the, not that, not that, this, between the book and the slides. So Auth conceptually is like a hierarchy that has two branches: authentication here on the left and authorization on the right. So authentication, it's checking you are who you say you are, that I am Josh Persi. I'm not someone else trying to claim I'm Josh Persi. So you can do this with your various ways. You can do this with a username and password that only I should know. You can do this with like passkeys or ID cards. Like if you want to get out of the tech world, like just an ID card saying I am who I am is the same idea of authentication. And then the book chapter has this idea of that it uses throughout this analogy that it uses throughout the chapter of getting into various rooms or buildings. So the goal of authentication is like you're walking up to a room, you have a guard outside the room, and you say, "Hi, I'm Josh Persi. Here's my ID card, or my username and password, or my token, or something." And the guard says, "Yep, looks good to me. Looks like you are who you say you are." And then I say, "Great, can I get into this room?" And then he asks the guard, he or she, they have to check whether I'm allowed access to that room. And that's the process of authorization. So they know I am who I say I am. That concern is put to bed. But now they need to know, am I allowed into this room? And that's authorization. So they look into various channels depending on the technology in place. But they'll either say, yes, you're allowed, come on in, or no, you're not. Sorry, you can't come in. So it's a binary yes, no authorization. All right. So that's authorization and authentication. Now let's talk about LDAP and AD. These are a few of the technologies discussed in the book. LDAP and AD seem to have come about in the early 90s, so before I was born. So I'm kind of imagining what the world looked like back then, but the internet wasn't really around. And most business was done over LAN, a local area network. So the risk, I guess, of like sending credentials outside of your local area network didn't really exist because the internet didn't really exist in its current state. So I think businesses could be a little more loosey-goosey with encryption and security. So that's just what I learned from a video. But LDAP was used kind of before the internet to within a business's local area network. And the idea here is that everyone in your enterprise has, I think, just one under LDAP AD. They have one set of credentials, my username and my password. And I can type that into a service like my email or a database. And that service passes those credentials to the Active Directory or Access Directory, excuse me, through a process called LDAP or LDAP, the Lightweight Directory Access Protocol. So like the protocol LDAP is the rules for exchanging that information, whereas the Access Directory actually contains the information that looks up my credentials. And if my credentials are found within that Access Directory, the LDAP protocol, the like guidelines, the rules of engagement between the service that I'm trying to access as a human being and the access directory. The access directory, excuse me again, the LDAP returns to the service that, yes, Josh Persi is who he says he is, and he's in our access directory. You can go ahead and give him access. Then I'll be allowed in to that service. This was great kind of before the internet because everything was contained within the network. So I don't think it mattered as much that the service technically was seeing my credentials because everything was in the local area network. Everything was like more secure. But nowadays in the web, if we're trying to access a service, it's actually, if we try to access a service using strict LDAP AD as existed in the 90s, I think that would be a security concern because the service would know our credentials and then it would send it to a external, like through the internet, it would send it to an access directory or an identity provider, an IDP. And I guess the credentials, if they weren't encrypted well, could be intercepted by a malicious actor. So some of the technologies we'll talk about later, I think, add on to LDAP AD to make it more secure. But at least as it was originally used in the early 90s, there was this kind of inherent security risk that, given the way the world worked at the time, wasn't super concerning because, again, everything was done on a local area network. So it didn't really matter that the service saw your credentials. The book uses this idea of you have multiple services. So again, email, database, admin account, whatever, or HR account. You have one set of credentials across all of those. And here it's simplified, and it doesn't really distinguish between the protocol and the access directory. But you're basically using the same set of credentials through the LDAP AD to access each service. So it's a little simplified. You as the user don't need to remember different credentials for each service. You have one set of credentials. Me at outlook.com, password is 123. Like, you can just use that for everything. Now, comments, questions, or corrections, but that was the world as it existed in the 90s before businesses used the internet. We now use the internet a whole bunch, and modern businesses are built to use it, to use the cloud. And this is where a technology called single sign-on has come in. So in the analogy of houses and rooms and buildings, single sign-on works more like this, where at the start of the day, you authenticate yourself. And this is kind of like authentication and authorization in one step. You contact your identity provider. For many companies, this is Microsoft Azure Active Directory, AAD, which is now called Microsoft Entra ID. And for me, there was a lot of confusion because that's Azure Active Directory, which sounds a lot like Access Directory. And they're kind of the same thing, but I guess they are technically different. But at any rate, the core idea of an SSO, of a single sign-on, is you pass your single set of credentials, Josh at AOL.com, password is 123. I send that to identity provider, which again is kind of like an access directory, I think, in the sense that it knows whether those credentials are within the enterprise. If my credentials are in the enterprise, it's able to say, yes, Josh Persi is like who he is he is who he says he is. and like he works here. We've authenticated him. So they send back an SSO token. Now, this token not only includes who a statement that like I am who I am, but it can include, I think, things like what I'm allowed to access. So it handles authorization in a sense as well. So it includes basically an audience. A token has what are called claims in it. I've learned this from other videos I've watched where each claim is like a separate piece of information. It's almost like a key value idea. So a claim regarding the audience tells me what services I'm allowed to use. A claim regarding the issued date tells me like when this token is active. You can also have a claim for expiry date that tells me when this token should invalidate or expire. But then once I have this token, I can pass this token to various services without sending my credentials. So it's more secure because these services never actually see my guarded credentials, my username and my password. They just see a statement basically that the identity provider, whether that's Okta, I can't remember the pronunciation, something like OKTA down here. I've never used it, but I'm more familiar with Microsoft Entra ID. So you basically contact your identity provider, your IDP. It says, yes, Josh is who he says he is, and this is everything Josh has access to, and this is how long this token should exist for. Maybe it should expire at the end of the day if my admins say I need to authenticate daily as a security measure. I can then go to every service, and maybe service one I have access to, and it'll let me in. Service two, I also have access to based on the identity provider's audience claim. So I get access to service two, but I try to get access to service three, but the SSO token doesn't say that I have access to it, so I'm denied. In this case, I might get like a forbidden 403 error, which says that it knows who I am. It has no issue with that part. It's just I don't have the authorization to access that service. So I'm getting denied forbidden access. Okay, so let's hop back to the slides. Going back to our rooms and buildings analogy, this is analogous to like you walk into a building, an office building, you get an ID card. So everyone you pass on the hallways, every room you try and enter, they know who you are. They know the front desk has checked you out. But then it's up to each, well, I guess that card in this case would also show like where you're allowed to go in the building. Maybe if you've ever been in a building like this, like it might say visitor, or it might say like needs a chaperone or something. So like there's some security guidelines on like where that person is allowed to go within the building. So this is managed by your browser's tokens. And this is an area where I'm not very familiar with, but it uses something called SAML, Security Assertion Markup Language, which again is like LDAP, the Lightweight Directory Access Protocol, in the sense that it establishes the rules a server needs to use, or service, excuse me, needs to use to connect or contact or verify that you are who you say you are. So in this sense, I think it's like a protocol, even though we call it a markup language. I'm a little fuzzy on the like computer science distinction between a protocol like LDAP, HTTP, IP, and a markup language, but I think they're both doing the same thing. They're establishing the rules of communication. I'm also not really sure where this technology comes in, like Open Identity Connect, OAuth 2, or in JSON, or maybe not even in JSON, but there's like a JavaScript web token, a JWT which you'll see like if you read additional documentation like I've tried to do, but I don't really understand where these fit in. They're used for something, obviously, but I don't really know where they fit in the larger auth workflow. But yes, let's move on.
Josh, if you don't mind,
Yeah,
I got a couple of
please.
questions just to see if I can cement my own understanding. Your presentation is super, super clear, by the way.
Oh, good.
Um, uh, for SSO, could you kind of think of it as, I don't know if this is too reductive, but basically as cloud-based LDAP that basically returns a token instead of returning like something else.
I think
Okay.
so.
All right.
That's my understanding. Yeah,
And the second part is for the services. So like in the diagram, you have service one, two, three. I guess there are some arrows. I feel like there might need to be some arrows of the services that are basically consuming. They take the token, and I guess they need to check the token back with the identity provider. Is that the way you think it
yes,
works? Okay.
yes. That's an excellent point, and I learned this in a video. There's another term. There's lots of new terms to me, but if you imagine I'm drawing a dotted line with my mouse here,
Yep.
there's a trust relationship between service two, between all these services and the identity
Yeah.
provider. So there's some sort of back channel where service two is checking whether that token is valid or like
Yeah.
came from the identity provider. It does this through a couple ways, and one that I learned that I think is pretty cool. So in a token, and this maybe gets into like cryptography, which is not a field I know much about at all. But each identity provider and each enterprise can have their own cryptographic key, which I think is just like a string of identifiable numbers and letters that is unique to
Okay.
that enterprise and that particular IDP's service. So sometimes, like imagine a 64 length character vector of characters and numbers that signals that is in every single token that signals that that token came from this identity provider in this enterprise. So it doesn't even need to like communicate back to the identity provider if the service knows to check for that particular cryptographic key. It just says, oh, that's like the cryptographic key we know our identity provider uses. So we know it has to be good.
Got it.
So
So
in
it's kind
that
of like
sense,
a
yeah.
cryptographic fingerprints.
Yes. Yeah, that's a
Yeah.
great way to put it.
And I imagine this probably gets rotated on a regular
I would think
basis. Yeah.
so. I would think so. Without like really the user like knowing it, I would imagine for security, you just like update your cryptographic key or fingerprint regularly.
Cool. Thanks.
Uh,
Thanks for that. I just want to make sure my understanding was approximately right. And
yeah,
it seems like
that's great.
it's
Thank you.
approximately right. Yeah.
Um,
Yeah, I wanted to share something. Well, first
Please.
I just I type Samuel in Google and it says I think the description of how the flow goes it's really good. So it says that yeah, it gets a user request through the service provider and then it gets redirected to the identity provider, and that's kind of like the first part of the diagram. And then the identity provider authenticates, and then the identity provider creates a SAML assertion, and that's kind of like
Okay.
the XML document, and it sent it back, and then the service has to validate the assertion from the identity provider. And I guess that's what Arthur was saying, that there's supposed to be like an extra arrow from the services to the identity provider to check the assertions, right?
Yes, I
Yeah.
believe so.
Okay.
And I
Okay.
guess in some of this, I wonder if we're all the way, like we're back to SSH in a certain sense. Like there's a
Mm.
private key that the services have that they know so that they can like they get this assertion, which I guess would be encrypted, and then they could do the kind of like backwards math to like decrypt this, or at least like verify that this is from the provider and understand what it means, right?
Mhm.
I don't know. That's a guess. I don't know if that's correct.
Uh, Although now I'm thinking if if that arrow that is missing, it only goes from the identity provider to the service and not back. Like the service has to like ask again, like to the
I'm
identity provider, like every time it wants to grant access. I don't think it should.
I don't think so either. I think it's
Hmm.
more intelligent than that, but I really don't know.
Okay.
Um, the more I learn about this, the more I'm impressed and surprised at the complexity of it.
Yes.
Like there's like even in this example, there's various uh, like this is a massive simplification. It's a good simplification because otherwise we wouldn't get it in this introductory chapter. But I've done a fair bit of like YouTube video watching, and it gets like very complicated very fast. Um,
Yeah.
maybe to that point, one thing I'll add is this other idea of like, so even when we send credentials to the identity provider, that's happening. If you, like me, use like are in a Microsoft team, my identity provider, Microsoft Entra ID, which was formerly called Azure Active Directory, and that is different than an Access Directory, kind of. Um, I'm sending my credentials through the web, which like externally. So my credentials are leaving like my local network, going to Microsoft Entra's IDs network. So even when I'm sending it, there's like encryption steps here along this line, and I guess a token is like by nature encrypted, but this step at least there's additional encryption that happens, and this is where other acronyms I've seen but I'm not very familiar with come in, like SSL, which is I think outdated now, but secure socket layer is like a method of encrypting that. And then TSL, the transport security layer, which is I think the modern replacement to SSL,
Yep.
comes into play. And okay, thank you for the confirmation, Arthur. So like there's many more acronyms and like steps here that are not shown.
Yeah. Yeah.
And
Mhm.
just to wrap up my thought here. So LDAP in the 90s, I think, was just plain text because it was again all local area network and you didn't really have to worry about encryption. But it's interesting to think about like uh, just like the advent of various technologies to solve these various issues, and kind of how they've all come about through time over the last few decades. But okay, that's my rant over. Please
Oh, yeah.
interject or add comments if you had anything to say.
No, yeah, I just wanted to share that yeah, like I know that Microsoft Azure used to like they let you use Active Directory in the beginning, like because I remember we developed like when I was in college we developed a portal an application and we needed authentication and we use Active Directory and the way that it will look is that like a it was like very simple. Like users had their username and we were using emails and a password. And it was like a simple data table
Mhm.
in like somewhere and yeah, like Microsoft will handle that. And then after some years, they said, no, we're gonna get rid of that. Like we're gonna use Auth 2, so everything goes to SSO, and people now have to use their Microsoft accounts if you want them to authenticate into any application that uses Azure.
Okay.
So yeah, like I don't know how they like I guess between being entirely on a LAN and having the internet but still using Active Directory. I guess that they added some layers of security, but then they completely got rid of it, or at least in Azure, and they moved completely away from that to SSO. But yeah, like as you said, it's super interesting, like getting to know how all these things are
Mhm.
have evolved.
Yeah, yeah, it's pretty cool.
Yes.
Um, Not to like totally, this is probably basic, but it is cool that this is like so SSO at least is like for me how I learned to use the web basically. Like I sign on to a lot of things with Google. Like you, if you've ever like been on a different web page that's not owned by Google, you can, there's often like a sign up with Google thing because Google's essentially, I think, being your single sign on. And it's uh, telling by going to Google, you're verifying who you are with their Active Directory or their identity as an identity provider. You're getting confirmed, at least for the authentication. And other companies trust that because like Google is Google and they're massive and they're everywhere. But yeah, just a cool example, I guess, of how SSO
Yes. Yeah, and like
within
as
your
a
personal
developer,
life.
yes, yes, and as a developer, like it makes your life easier because you don't have to handle authentication. You
Yeah,
don't have to worry about yeah, that part of the security in your app, and
yeah,
it's just like yeah, they do that, and you just take it as it is. Yeah.
that's a good point. That's a good point. From a sorry, one second here. Just keep,
Yeah. I don't know if like the from the user point of view, I guess it's also. I don't know if it's better. Yeah, sometimes I don't know if it's good that Google has all of our.
yeah,
Yeah,
I
yeah,
feel a little weird that Google knows like everything
yeah,
I've ever signed up with using it. And I've at times tried to not use Google, but
yeah,
yeah, it's
yeah.
as a developer, like if I was to develop like an app or something, like I also see the attraction that I could just focus on what I think makes my app cool and leave authentication to Google.
Hmm.
Okay, let's go back and see what the slides have to say. Okay, so I think the last part of this chapter is all about permissions. And I guess there are really three things to know about permissions. There is an access control list, an ACL, which per service lists, as far as I understand, per service lists names of users and what they can do. So it might say Josh Persi has read access. Diana has read and write access. Arthur, an admin, has read, write, delete, update access. So I really don't have a sense of how often that's used, um, but it's one way, I guess, to give permissions to your users. So like once they've authenticated, once they've authorized themselves, this is a sense of, I guess, like authorized that they are able to access the service. Permissions say what they can do while they're using the service. What I'm more familiar with is role-based access control. So it defines groups of permissions. I think this is the idea of like a viewer role where you basically just have read access, a contributor or editor role where you have the ability to make changes, and an admin role might have like a delete or change settings permission. So it seems very similar to an access control list, except here you're defining the permissions of a group and who is in that group rather than the similar but different. Here's all the people. What permissions does each person have? So it's maybe a way just to bucket permissions. I don't know quite what the original author meant here by complexity creep for each person who thinks they're special. Um, to me, that kind of seems like something that might happen more in an ACL.
Maybe
correct me
that's
if you
me,
feel
like you
otherwise.
create a special group for a person that has special privileges. I don't know. That's my guess.
Okay, that's a good point. I had that thought too, but I've really haven't seen like special groups. Like I've seen like viewer viewer or reader, editor, contributor, owner, or admin kind of like on the various tools I've used. I haven't seen someone create like a special group where it's like special group created for marketing team executives or something like that is a very niche group. But have you seen tools that use roles like that?
In a certain sense, I've seen where, maybe once, so for example, at work, we're not allowed to use Docker as the default. Instead, you need to be added to a Docker group in order to do that. So I'm
Ah,
guessing
okay,
that
yeah.
that would be a group that would have a certain set of permissions for using Docker or Podman or something like that.
That's a good point.
Um, yeah. I mean, here I'm thinking about just a local device. I don't know if that if my idea extends to data science servers. I would imagine so, since it's just another computer, but I could be wrong.
That's a good point. And I think it hits at something that I was misunderstanding. So I was thinking of like a web platform, like maybe like if you're thinking of like GitHub or Power BI or like Tableau or something, you often have like set permissions, but at a layer deeper than that, like that your IT admins have access to, they can create user groups, which are groups of users with particular access. Like they can use these people can use Docker and or these people can access this database or something like that. Um, in which sense, I totally get what they mean when they say groups of permissions for people who think they're special. Okay. I think that makes more sense to me now. Thanks, Arthur. The last of the big three permission types approaches is ABAC, attribute based access control. I assume people say ABAC instead of a back, but maybe I'm wrong. So this one defines permissions for like a combination of attributes. The book doesn't really provide an example, but one that I found online that seems interesting is like you as an individual can read this data if a certain attribute says you are like on the Office more secure network and you are a part of this group. But if you are trying to read that data, for example, from your home network, unsecure, likely, you don't have access. So it uses the attributes of like maybe your IP and your username and possibly even like what time of day it is. I saw an example where it's like users can read this data up until 12 and then it's down for, I don't know, some sort of reason. So I don't know when businesses would really use this, like what use cases they would have for enacting what sound like more strict and strictly defined permissions based on where you are, who you are, the task you're doing. Um, but this exists. It sounds like it's harder to implement than role-based access control or an access control list. But I guess if you need it for a particular business use case, like it's there for you to use.
My only case that I'd seen, and maybe this is a misunderstanding, this is the one that have in the bottom is a IAM with AWS. I don't know if this is, by the way, I don't know if this is a general um, concept or if it's just something that exists with AWS. I've run into when doing some stuff on AWS is I would imagine like let's say you have a project that has a set of users that can access a service. Maybe one of those users is like a service user, so it's like your script that runs. You could say like for this project, for this user, it can access these data, right? Even if everything's within the network, if it still belongs in the network, you can have more fine-tuned um, controls like that. That's the use case I've seen, I think,
Okay.
but I've not had too much exposure to that, and I'm not sure, even though it's listed here, if that's really an example of attributes based access control. Diana, I feel like you've worked a lot more with cloud stuff. Do you have a better grasp of this?
No, I don't. Yeah, no.
All good. It'll
No.
remain a mystery, I guess, for us.
Yes.
Well, over the coming months, if any of you all of a sudden start using ABAC, let us know.
Yeah, actually, yeah, I didn't know about ABAC. Like it's the first time that I've seen that acronym.
Okay.
But
Uh,
yeah.
so like this is all cool. It's fun to like kind of nerd out about admin auth and understand how the internet works. Um, but as a data scientist, you probably like you are not the IT, you are hopefully not the admin IT person who needs to know all of this. So as data scientists, presumably, people more focused on like analyses, visualizations, data pipelines, things like that, modeling. How much of this do we need to know? And when will knowing it be valuable? Data access. Um, you often need to pass credentials or authenticate in some way to access that database. You will also need to authorize what you're allowed to do, or I guess be part of a permissions group that defines what you're able to do with that database, whether it's read or read and write. There's lots of other stuff on this page that I don't really know how it slots in, like Kerberos um, is another idea, older technology, I think, but more secure, according to the book, that kind of does the same thing for authentication and possibly authorization. Um, some of this is cut off, but yeah, I guess how I'll end it is it's cool to know this stuff if you like understanding more about how the world works and the internet works. But it's also probably not our day jobs to know all the nitty gritty, just enough to intelligently communicate with um, admin when they say your new data workbench needs to use single sign-on, and you can just know what that means. Um, okay, so I think that's everything I have to say. Any additional questions, comments,
Kind
rants,
of a follow-up
diatribes?
on your point, Josh, is like
Mhm.
I mean, I feel like maybe it might be helpful to have this mental model of how the world works outside of your application. But I am wondering, like, how could you help IT to get at the root cause? I mean, I guess all you would be able to say is like it doesn't work on my machine. Like
Yeah,
it doesn't work on like the cloud machine, where I've got things set up. Like I can't access the data, but is there a way you can know why you can't? I mean, maybe if you're working in cloud infra, maybe I don't know, Emil. I'm thinking like imagine you have an interactive session on like an EC2, like a Linux EC2 instance on AWS, and you've got it's accessing data on another instance on AWS, like RDS instance or something like that, and you can't access the data. Maybe like that RDS sends back something that tells you that like.
yeah.
Yeah, I don't know.
I
It's just kind of like how would you know? I mean, I guess hopefully it's not your responsibility to know unless like you're owning the whole stack, and maybe you do for
yeah,
prototypes. I don't know. I've
maybe
not
yeah.
ventured into this world, but I'm kind of wondering like how in practice do you do you know what's going wrong except to just say, hey, I can't access the data, and then it's IT's responsibility to sleuth
Yeah.
around and figure out why.
For me, I think some of the takeaways are if you have a bang up, like top of the shelf, grade A, excellent admin team, you could probably just like send them the error message you get and they'll figure it out. But for me, knowing things like the 403 error that you might get tells you that you've authenticated successfully. So the issue isn't with authentication, but it's with your authorization or permissions, like narrows the scope of where the issue might be. Um, Again, things like that, things like saying, like knowing whether you're, for example, accessing a database through, like if your admin says we use LDAP to access our database, you're going to have to like enter in your username and password in like probably in code or in some sort of place like that. Whereas if they say we use SSO, you're probably going to have to authenticate through like a web browser pop-up. Um, or maybe some of the takeaways that I'll have, like some databases use older LDAP, and maybe I should be advocating that we like maybe I shouldn't be advocating because I'm not an IT admin, but like it'd be great if we had SSO and it was just easier for me to access this database instead of having to contact you for the latest set of credentials for it. But I'm also not sure how this will work in to my daily work. It's just cool to, I guess, know how the internet works a little bit better. Okay. Um,
Do you guys have a sense of whether IAM is a AWS only thing, or is it kind of like an increasing standard? I could Google, but I'm just curious if you
yeah,
happen to know.
I thought it was
Mm.
stand like okay, so like Microsoft here has identity access management.
Yeah, I think they all have like a similar thing, right?
I think so, yeah. I don't think it's a unique branding term for
Yes.
Amazon.
And and I think they also kind of they try to make your life easier by I mean by kind of like mm, giving you a set of these policies like together if they know what kind of role you're gonna have. Because like yeah, AWS knows that you need this policy to read a database, but you also need like another very specific policy to I don't know, maybe go into a single table or I don't know, it's a bunch of policies. And then it can I feel like it kind of goes to a like a role like the other type of authorization, like a role-based authorization when they kind of bundle a bunch of policies into a single role. And I guess that's what makes life easier for IT managers because you like it will be uncommon for someone to have a really weird error if you kind of have like the same roles per team or
Mhm.
per department, no?
Yeah.
Mm,
Yeah, I see the logic of like role-based access control for sure.
mm-hmm.
One just to share in case you're interested, one thing that I found helpful was this video series that explains two videos in particular. I will just I won't play them. But when we were talking earlier about the relationship, the trust relationship between the service and the identity provider, he talks about this trust relationship and how it's communicating between the access directory, IDP, and the service. So he has some helpful diagrams there. And just in the world of IT admin, there's this like complicated graph that shows like the process of a service connecting to all the various players in this arena. And it gets pretty complicated pretty quick with like multiple return trips to like verify everything. So I found these super helpful if you wanted to dig in with a little more detail. But that's everything for me. I'll go ahead and write end in the chat.